we have been working on model development, and if you remember, um, your network to develop a model, we need to find the best set of hyperparameters. So we call these list of parameters are hyperparameters, because if we have a neural network, we have these weights here, but it's also called parameter of the model. And these list of parameters different from this, but this is also called parameter, and it's confusing, so we call it hyperparameter, because this size, well, not this size, but it makes influence on the training process. So different set of hyperparameter ended up with different parameters in the model, so we call this is a hyperparameter. And actually there are too many options for the hyperparameter, so we're gonna use this tool Optina to help to get some help on to find the best hyperparameter for the model development. So we can see the code example. So you'll do it here. First, you need to install. Okay, so let's install it. Anaconda prompt, and then install this pip install Optima. Okay, and there's one thing you need to understand, that is cross-validation. So we're gonna use cross-validation. I explained that in the model development we need training data set, training set, and test set. So it's good to test the model. So this training set is used to train the model, which means models parameters are decided based on the training set. So it's obvious that model works well for the training set, but it's not guaranteed yet if it works well for the test set. So we do the test set, but there's another issue here, which means this test set is used to select the good parameter of the model. So it's used to select the model. So we're not really sure if the model is tested with a blind test. We don't know yet if it works well or not, because the model should work well and it's selected based on this, so it should also work well for the test set. But what if there's an unseen data, real unseen data? If the model is deployed, users will input any type of data set, and we don't know yet if the model also works as much as it did for the training and test set. So actually there should be another set of data called validation set. Validation. It should be used to select the model with the validation data, and we do the final test on the test set. Then this test set is not used to train the model, and also it's not for selecting the model. So there should be another set called validation set. But in our case, we don't have enough data. We have just 80 data points, so we cannot really divide it to for the validation set. At the moment it's around 6 and 20, but if we assign another data set like a validation set, then training set should be like a 40 and it should be 20, which is not really good thing in this case, but we need anyway validation. So we didn't use validation set, but use internal validation. Internal validation. There are many different methods for this, but here we're going to use cross validation. So the full name is cross validation. And you see cross validation also has many different parameters, but here is CV equals 3. So we call it threefold. I'm going to use a acronym threefold CV. What it does, it divides the data set into 3 chunks. 1, 2, 3. So I divided it into 3, and now I'm gonna develop the model with one. Let's number it. Use data 1 and 2, chunk 1 and 2, and develop the model, and use number 3 for validation. 3 is used for validation, and we repeat this with chunk 1 and 3, and then validate with 2, and then use 2 and 3 for training, and then validate it with number 1. In that case, we develop 3 different models, and we get 3 validation. We get 3 test result, and we have an average value of these 3 test set, and we consider it as a validation set. So it's like a validating the model 3 times, and we see that if the model works, model gives pretty good result on these 3 times of internal validation, then we consider that the model will work well for the test set also. So this is a method that we are not separating the validation set from the entire data set. Rather, we use the entire data set, but testing the model and also training the model. So this internal validation is used particularly when the data set is not sufficient. And by doing so, we can use all the data set in the training set, and also we get the validation result with this approach. So it's called cross validation. So from now on, our approach to model development is this. So we have a training set, but we use threefold cross validation and get the validation result and test the model with the test set. So by doing this, we can find the best hyperparameter that works very well for the validation, cross validation, and then we assume that these hyperparameters, best hyperparameters working well on the validation, cross validation, can be also working well for the test set. So that's quite essential for hyperparameter tuning here.